Now we are like, we theoretically read about it. Now with respect to AWS, we want to actually understand that scalability and AWS and availability, high availability, high scalability in AWS, how it can be achieved. Okay, so we are going to target that how can we achieve this in AWS. This is something that we are going to try with. This is something that you are going to try. Okay. So just to revise. Okay. Scalability means that an application or system can actually adapt to handle higher loads altogether. Okay, so that's mainly scalability, and technically you have two types of scalability up with you: vertical scaling and horizontal scaling. We already talked about it. Right, in vertical scaling, what we do is we try to actually improve the, I would say, specs of your machine. Right, let's say if you were already having, let's say, a 1 GB RAM machine and a single core processor CPU, maybe just like T2 micro or something in AWS, then you can actually enhance your machine and deploy on a, I would say, higher, I would say, performant machine altogether. Whereas in horizontal scaling, what you can actually do is you can try to spin up multiple machines of maybe equal power and not that powerful, but you'll be having multiple more machines spinned up, right, so that they can distribute the overall load upcoming ahead. Okay, cool. So we can say that to achieve vertical scaling, to achieve vertical scaling in AWS, we can opt in for more powerful EC2 instances. We can opt in for more powerful EC2 instances, right? Like, for example, if you see your free tier, in your free tier, you get a machine T2 micro, right? What you can do is you can opt in for something which is far more powerful and far more performant as compared to T2 micro altogether. Okay, so now let me even show you a demo. For example, if you go to EC2 and you try to spin up a brand new EC2 instance altogether, you can see I have a couple of instances already running, right? If let's say if I click on launch instance, and now you can see this is the operating system that you can select. Operating system is independent of the power of the machine, right? So you can select any operating system altogether. But the moment you come to instance type, this is the place where you actually decide the configuration of your machine. For example, in the free tier, we get the T2 micro. The moment you open it, you can see you get if you want, you can get an even less powerful machine, that is T2 nano. Then you have T2 small, T2 medium, T2 large, T2 extra large, and so on. You can see, and there is like a humongous tier of, I would say, configuration that is available. You can see if like you go for very powerful machines like this, you can have a 12 core CPU, 96 gigs of, I would say, RAM, so on and so forth. Like very powerful machines you can actually get. And even if you like upgrade a small, like for example, from T2 micro to small, T2 small, if you go, then your RAM from 1 GB RAM, you will be upgraded to 2 GB RAM. That's like improving the overall power of your machine, right? That's what your vertical scaling is. Now, to achieve horizontal scaling, to achieve horizontal scaling, we can spin up multiple EC2 instances and manage the traffic on them using load balancers. So we already talked about load balancers. So what we can do is we can actually spin up multiple instances altogether, and then in order to manage them so that the requests are routed properly, we can actually instantiate load balancing. right? So technically, I'll talk more about this horizontal scaling stuff, but technically there can be two type of horizontal scaling. One is auto scaling, where automatically these instances will be spinned up and attached to a load balancer, or there can be manual scaling that you can do. Depending on situation to situation, depending on requirement to requirement, this thing can actually change. Okay, so that's for scaling. But when you say for high availability, right? If I talk about specifically around availability, then high availability can be actually achieved if you keep your data and you keep your server instances in multiple regions and availability zones. Okay, so if you are going to keep, let's say, your server instances in multiple availability zones, then even if due to any reason one of the availability zone is affected, the other availability zone will start actually routing your traffic altogether, right? That can be something that can be useful. Okay, so this is like how you can actually achieve vertical scaling and horizontal scaling altogether in EC2 instances. Okay, now there is a term, like, you know, about scalability. There is a term called as elasticity as well. Okay, so I would like to talk about that also. Okay, so you can say scalability is the capability of a system to accommodate more load, right, and handle it accordingly. Now there is one more term called as elasticity. There is one more term called as elasticity. Now what is elasticity? Okay, now once a system is properly scalable, once a system is properly scalable, right, elasticity means that there will be there will be automatic scaling, right? There will be automatic scaling applied on the system, applied on the system, right, based on the load. Right. So elasticity refers to the fact that, let's say, if you do not have enough load, there is no point of having too many servers spinned up. You can actually scale down your system. If you're getting too much load, then you can actually scale up your system as well. Like, there is some kind of flexibility in this scalable appreciation, right? For example, like, you can make your system by spinning up, let's say, 15 instances of your EC2 instance. But that's not, I would say, economical as well for you, right? You won't be having same amount of traffic throughout your month, right? Such that you need all 15 instances every time running. Yeah, you can keep some cold instances already, but you don't need all of them running, because they are going to be also, I would say, chargeable to you. So better would be that if you anticipate some specific load, for example, if you're an e-commerce application and you know that the last 3 days of the months are the sale days for our application, then at that point of time you can pre-prepare yourself and then spin up multiple instances. Before that, you can maybe keep your system relatively scaled down, maybe to at least 6 to 7 instances altogether. This will also save you cost, and this will make your system more rigid and more powerful altogether. That's what elasticity in the reference of scalability and availability actually means. Okay, now specifically talking about horizontal scaling. Horizontal scaling can be achieved by spinning up multiple instances altogether. Okay, spinning up multiple instances altogether. Okay, let's say this is one EC2 instance, this is one more EC2 instance, and so on. Okay, now just think about it. Each EC2 instance has its own IP, let's say IP1, IP2, IP3, IP4. When our clients have to communicate with these EC2 instances, how do they know which IP to hit? Because they do not know, the client, let's say your front end doesn't know that which EC2 instance is having higher amount of load, which EC2 instance is having lower amount of load, and so on. And that's where the picture of load balancer also comes into the picture. Like, we already talked in detail about what is load balancer and everything. So you can say that load balancer is going to sit in front of the EC2 instances, right? Any request that is going to come from the client side, any request that is going to come from the client side, okay, is going to be redirected, to different EC2 instances altogether, right? Different EC2 instances altogether, right? Depending on how much amount of load they are actually having. This is called as load balancer. Okay, so you can say that This is capable of, it is capable of forwarding internet traffic to multiple EC2 instances. Okay, multiple EC2 instances altogether. That's where your load balancer will come into the picture. Okay, and like, why do you want to use a load balancer? Because it is going to help you to spread your load across your EC2 instances, right? And apart from that, what will happen is, now if the client has to communicate, they will just need to know the IP address of your load balancer. That's it, right? By knowing the IP address of your own load balancer, yeah, they do not need to actually care about where exactly their EC2 instances are hosted, right? They will just hit the load balancer altogether, and load balancer will automatically redirect your requests forward. That's the main part. That's an important aspect of doing horizontal scaling altogether. Okay. And it will also help you to do health checks for your instances. It can also do health checks for instance, right? It can be a push model based or a pull model based health checking mechanism that also the load balancer can actually introduce. So there are a lot of things. There are a lot of things that this load balancer is capable of. And again, as I talked about the types of load balancer, there is an L7 load balancer and L4 load balancer as well. So AWS also provides us different types of load balancer. Okay. So let me talk about it. Okay. So technically, the first type of load balancer is application load balancer. Okay, this is kind of like a L7 load balancer. Okay, then there is a network load balancer. There is a network load balancer that is provided by AWS. This is an L4 load balancer. And then there is one more called as gateway load balancer. Okay, so you already know about, okay, so as you already know about L7 load balancer, right, that this is going to work with your, I would say, HTTP and HTTPS kind of protocols, right? Network load balancer is going to work with your TCP and UDP protocols, and this is much more performant altogether. Like all of these, I would say, load balancer services that AWS actually provides comes under the category of elastic load balancer. Okay, you can say that elastic load balancer is an AWS managed load balancer. Okay, because you can also spin up your own load balancer. Like you can spin up your own EC2 instance, which can act as a load balancer. You can write the algorithm for balancing the load across your other EC2 instance. You can do all of those things manually, but that is going to take a lot of effort from your side in order to manage all of these traffic. Okay. Whereas this elastic load balancer is kind of like the service that actually provides you the capability to host any one of these three load balancers. Okay. In this case, if you use the elastic load balancer service, AWS manages the high availability, upgrades, and maintenance of the load balancer, right? So everything will be actually maintained by and managed by AWS altogether. Okay. And of course, like you have to take very less, I would say very less hassle altogether in order to manage this. One more thing, that there is one legacy type of a load balancer also. I guess that is called as a classic load balancer. But they are, I guess, deprecating the classic load balancer, and you have these main three categories of load balancers altogether. If I talk about the application load balancer, this is capable of like actually interacting with the HTTP and HTTPS kind of request. If you're making a REST API, if you're making a gRPC API, anything, you can actually balance it on your EC2 instances using the application load balancer. If you need like very high performance, like then you can actually use network load balancer. This is generally for like millions of requests per second if you are actually hitting, right? And you can also attach a elastic IP that will act as your static IP altogether to this network load balancer. Okay. And then if you want to actually route your traffic to firewalls and do any intrusion detection, then you can actually use gateway load balancer for our use case, like most of the dev use cases in the companies, you will realize that actually day to day you will be interacting with a lot of application load balancers thing. Okay. Now what we'll try to do is we'll try to spin up, let's say a couple of servers, right? We'll write some code there, and then based on that, what we are going to do is we are going to attach the load balancer to it, and we will see that how load balancer is going to start routing our request altogether. So let's try to do this hands-on on AWS.